हेलो गाइस, आप लोग कैसे हो? मैं अजीत प्रताप यादव आप लोगों के लिए नई वीडियो लेके आ गया। आज इस वीडियो में डिस्कस करेंगे क्लास साइंस 9 साइंस चैप्टर 10 वर्क एंड एनर्जी। तो वर्क एंड एनर्जी को मैं क्या है 100 क्वेश्चन एंड आंसर के हेल्प से डिस्कस करूंगा। तो गाइस लेट्स स्टार्ट नाउ। पार्ट 1, वर्क एंड इट्स कैलकुलेशन। Question number 1 to 25. What is work? Work is said to be done when a force applied on an object causes a displacement of the object in the direction of applied force. What is work? Work is said to be done when force applied on an object causes displacements on the object in the direction of the applied force. Write the mathematical expression for work. Work W equal to force multiplied by displacement. W equal to force F multiplied displacement S into cos theta, where theta is angle between the force and displacement. This displacement is vectors. Now, question number 3. What is the SI unit of work? SI unit of work is Joule. Joule. Joule equal to 1 Newton multiplied by 1 meter. Question number 4. Define 1 Joule of work. 1 Joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter in the direction of the force. Question number 4. Define 1 Joule of work. Answer is that 1 Joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter in the direction of the force. Question number 5. When is work done considered to be zero? Give an example. Work done is zero when there is no displacement or when the force is perpendicular to the displacement. Example, a person pushing a wall failed to move it, no displacement. Example 2, a coolie carrying a load on his head and moving horizontally, force is vertical, displacement is horizontal. Question number 5, when is work done considered to be zero? Give an example. Work done is zero when there is no displacement or when the force is perpendicular to the displacement. Example, a person pushing a wall failed to move it, no displacement. Example, a pulley carrying a load on his head and moving horizontally, force is vertical, displacement is horizontal. Question number 6, a force of 10 Newton is applied to an object displacing it by 5 meter in the direction of the force. Calculate the work done. W equal to F into S. A force of 10 Newton is applied to an object displacing it by 5 minutes in direction of force. Calculate the force. W equal to F into S equal to 10 Newton multiplied by 5 equal to 50 Joule. Question number 10. A body of mass 10 kg is lifted to the height of 2 meter. Calculate the work done. G equal to 10 meter per second square. Answer, force required F equal to mg multiplied equal to 10 kg multiplied by 10 meter per second square equal to 100 newtons. Work done, W equal to F into S, 100 minus multiply 2 meter to 100 joule. Question number 8. What is the work done when the force on an object is perpendicular to the displacement? The work done is 0, since theta equal to 90 degree, cos 90 degree equal to 0. So W equal to 0. Question number 9. A man carries a suitcase horizontally. What is the work done against gravity? 0, because the displacement is horizontal, while the force of gravity which he is working against is vertical. The angle between the force and displacement is 90 degree. Question number 10. Is work is scalar or vector quantity? Answer, work is a scalar quantity. It has only magnitude and no direction. Is work scalar or vector quantity? Work is a scalar quantity. It has only magnitude and no direction. Question number 11. Can work be negative? Explain with an example. Answer, yes, work done is negative when the force and displacement are in opposite direction. Theta equal to 180 cos 180 degree equal to minus 1. Example, the work done by the The work done by the friction when a body slide on a surface, friction opposed motion. Question number 12. What is the work done by the gravitational force on a body moving upward? Answer negative work because the gravitational force downward and displacement upward are in opposite direction. Question number 12. What is the work done by the gravitational force on a body moving upward? Negative work because the gravitational force downward and the displacement upward are in the opposite direction. Question number 13. What is the work done by the gravitational force on a body of moving downward? Answer is the positive work. Positive work because the gravitational force downward and displacement downward are in the same direction. Question number 14. A force act on a body but does not work. Give two possible reasons. The body has no displacement, so the force is perpendicular to direction of displacement. Question number 14. A force act on a body but does not work. Give two possible reasons. Answer the body has no displacement. Question number 2. The force is perpendicular to the direction of displacement. Question number 15. A crane lift a 500 kilogram mass to a height of 10 meter. Calculate the work done by the crane is equal to 10 meter per second square. Answer force F equal to m into g equal to 500 kg multiplied by 10 meter per second square equal to 5,000 Newton. Work W equal to F into S equal to 500,000 Newton multiplied by 10 meter equal to 50,000 Joule or 50 kilojoule. Question number 16. A body pulls a toy car with the force of 5 Newton on a horizontal surface. The car moved 2 meter. What is the work done? W equal to F into S equal to 5 n गुणे 2 meter equal to 10 joule. Assuming force is in the direction of motion. Question number 17. What is the angle between the force and displacement for maximum work done? Theta equal to 0 degree cos theta equal to 1, which is maximum values. Question number 18. What is the angle between force and displacement for minimum work done? Question number 18. What is the angle between force and displacement for minimum work done? Answer is 180 cos 180 equal to -1. Question number 19. A force of 7 Newton act an object at an angle of 60 degree to the direction of displacement. If that object moves 4 meter, calculate the work done. Answer is W equal to Fs cos theta. 7 Newton multiplied by 4 meter multiplied by cos theta equal to 28 multiplied by 1 by 2 equal to 14 joule. Question number 20. A body move in a circular path. What is the work done by the centripetal force? 0, because the centripetal force is always perpendicular to the direction of displacement, tangential at the every point. Question number 21. Name the physical quantity which is the product of force and displacement. Answer is work. Question number 22. When a book is lifted from a table, who does the work? The person lifting it or gravity? Answer the person does positive work against gravity. Gravity does negative work on the book. Question number 23. What is the CGS unit of work? ERG. 1 erg equal to 1 dyne multiplied by 1 centimeter. Relate joule and erg. 1 joule equal to 10 to power 7 erg. Question number 25. A battery lights a bulb. Describe the energy chain. Chemical energy in the battery equal to electrical energy, light and heat energy in the question part 2. Energy kinetics and potential energy. Question 26 to 50. Question number 26. What is energy? Energy is the capacity of a body to do work. The SI unit of energy is joule, the same as work. Question number 26. What is energy? Answer is the energy is the capacity of a body to do work. The SI unit of energy is joule, the same as work. Question number 27. Define 1 joule of energy. Answer: a body is said to be have 1 joule of energy if it can do 1 joule of work. Question number 28. What are the different form of energy? Answer is kinetic energy, potential energy, mechanical energy, and heat energy. Chemical energy, electrical energy, nuclear energy, light energy, etc. Question number 28. What are the different form of energy? Kinetic energy, potential energy, mechanical energy, heat energy, chemical energy, electrical energy, nuclear energy, light energy, etc. Question number 28. What are the different form of energy? Answer is the kinetic energy, potential energy, mechanical energy, heat energy, chemical energy, electrical energy, nuclear energy, light energy. Question number 29. What is kinetic energy? The energy processed by a body by virtue of its motion is called kinetic energy. What is kinetic energy? The energy processed by a body by virtue of its motion is called kinetic energy. What is kinetic energy? The energy processed by a body by virtue of its motion is called kinetic energy. Question number 29. What is kinetic energy? The energy processed by a body by virtue of its motion is called kinetic energy. Question number 30. Write the formula for kinetic energy. Kinetic energy K equal to half multiplied mass multiplied by velocity E square. Question number 30. On what factor does the kinetic energy of body depend? Answer: it depend on the mass and of the body Ke multi proportional to second the square of the velocity of the body Ke proportional to V square. Question number 31. On what factor does the kinetic energy of body depend? It depend on first the mass of the body Ke proportional to m. Second, the square of the velocity v of the body Ke proportional to v square. Question number 32. A car of mass Question number 32. A car of mass 1000 kg is moving with the velocity of 10 meter per second. Calculate its kinetic energy. Answer: Ke equal to half mv square equal to half multiplied by 1000 kg multiplied by 10 meter per second equal to 500 multiplied by 100 equal to 5000 joule or 50 kg. Question number 33. If the velocity of body is doubled, what happened to its kinetic energy? Kinetic energy become 4 times Ke proportional to V square. Question number 30. If the mass of body is halved and its velocity is doubled, what is the change in its kinetic energy? Answer: original Ke equal to half mv square, new Ke dot equal to half m upon 2 v square equal to half multiplied by m upon 2 to 4b square equal to mb square. New kinetic energy upon original K equal to mb square upon half mb square equal to 2. So the kinetic energy doubles. Question number 35. What is the potential energy? The energy processed by a body by virtue of its position or configuration is called potential energy. Question number 36. Write the formula for gravitational potential energy. Potential energy P equal to mass multiplied by acceleration due to the gravity. Question number 37. On what factor does the gravitational potential energy of a body depend? Answer is: it depends on the mass of the body. Second, the height of the body from the reference level. Third, the acceleration due to the gravity G. Question number 38. A body of mass 5 kg is placed at the height of the 10 meter. What is its potential energy? G equal to 10 meter per second square. Answer: P equal to mgh equal to 5 kg multiplied by 10 meter per second square multiplied by 10 m equal to 500 joule. Question number 39. What is the potential energy of a body at a ground level? 0, since height h equal to 0. Question number 40. A ball is dropped from a height. What is the energy transformation that take place? Potential energy is converted into kinetic energy. Question number 40. A ball is dropped from a height. What is the energy transformation that take place? Answer is potential energy is converted into kinetic energy. Question number 41. Give two examples where body possesses both kinetic and potential energy. Answer is the flying aeroplane. B. A bird flying in the sky. Third, a stone falling from the cliff. Question number 41. Give two example where a body possesses both kinetic energy and potential energy. Answer: one, a flying aeroplane; second, a bird flying in the sky; third, a stone falling from the cliff. Question number 42. Define mechanical energy. The sum of the kinetic energy and potential energy of a body is called its mechanical energy. Mechanical energy K equal to P. Question number 42. Define mechanical energy. The sum of the kinetic energy and potential energy of a body is called its mechanical energy. Mechanical energy equal to Ke plus P. Question number 43. State the law of conservation mass of energy. Energy can neither be created nor destroyed. It can only be transferred from one to another. The total energy in an isolated system remain constant. Now question number 44. Question number 44. As satellite revolve around the Earth in a circular orbit, its kinetic energy is constant. A satellite revolve around the Earth in a circular orbit. Is its kinetic energy constant? Answer is that for a circular orbit, the speed is constant, so its kinetic energy remain constant. Question number: for a circular orbit, the speed is constant, so its kinetic energy remain constant. Question number 45. In the same orbit, Question number 45. In the same orbit, is the potential energy of the satellite constant? Yes. For a circular orbit, the height of is constant, so its potential energy remain constant. Question number 46. What is the commercial unit of energy? Kilowatt per hour. kWh, kilowatt per. Question number 47. Define 1 kilowatt hour. 1 kilowatt hour is the energy consumed or work done when a device of power 1 kilowatt is used for 1 hour. Question number 48. How many joules are there in 1 kilowatt hour? 1 kilowatt hour equal to 1000 watt multiplied by 36 second. 36 3 lakh 6 3 crore 60 lakh joule, 3.6 multiplied by 10 to power 6 joule. 36 lakh. So what is power? Power is defined as the rate of doing work is called power. Question number 48, 49. What is power? Rate of doing work is called power. What is power? Rate of doing work is called power. P equal to W upon T. Question number 50. What is the SI unit of power? Watt. W equal to 1 watt, 1 joule per second. Question number part 3. Power commercial unit and calculation. Question 51 to 74. Question number 15. Define 1 watt. A body is said to be have a power of 1 watt if it does 1 joule of work in 1 second. Question number 52. What is the bigger unit of power? Kilowatt per hour. 1 kilowatt equal to 1000 watt. Question number 53. A body of mass for 50 kg run up a staircase of 30 steps is 20 centimeter high in 50 seconds. Calculate the power using G equal to 10 meter per second. Total height H equal to 330 multiplied 2 point meter equal to 6 meter. Work done W equal to mgh 50 kg multiplied by 10 meter per second square multiplied by 6 meter equal to 3000 joule. Power P equal to W upon T. So power is given 3000 multiplied by 15 as you will get 200 watts. Question number 54. Two children A and B complete a task in 10 seconds and 15 seconds respectively. Who has more power and why? Child A has more power because the same work is done in less time. P proportional to 1 upon T. Question number 55. An electric bulb of 60 watt is used for 5 hours daily. How much energy is consumed in 1 day? Answer: energy equal to power multiplied by T equal to 60 watt multiplied 5 hour equal to 3 hour. 300 watt hour, 0.3 kW. Question number 56. An electric heater is rated 1500 watts. How much energy does it use in 2 hours? An electric heater is rated 15 watt. How much energy does it use in 2 hours? Answer: energy equal to power multiplied by time equal to 1.5 kilowatt hour multiplied to H equal to 3 kilowatt hour. Question number 57. What is the horse power HP? So it is a unit of power used in the British system. 1 HP equal to 746 watts. Question number 58. An engine does 30,000 joule of work in 1 minute. Calculate this power in watts. P equal to W upon T equal to 30,000 joule upon 60 equal to 500 watt. Question number 59. Why is the term work different in science compared to the everyday life? In everyday life, any physical or mental activity is called work. In science, work has a precise definition. It requires both force and displacement in the direction of force. Question number 60. A girl is swimming. At which point is her kinetic energy maximum? Kinetic energy maximum at the lowest point of the swing. A girl is swing. At which point is her kinetic energy maximum? The kinetic energy maximum at the lowest point of the swing. Question number 60. In the same swing, at which point is her potential energy max? Potential energy maximum at the highest point of the swing. Question number 62. Spring is compressed. What type of energy that it possesses? Elastic potential energy. Question number 63. Derive the formula of our kinetic energy. K equal to half mv square. Answer is: let a body mass m initially at rest be acted upon by a constant force F, which cause displacement S and produce velocity V. Work done W equal to F into S. From Newton's second law, F equal to ma. From equation of motion, V square minus C square to S, since U equal to 0, V square equal to 2S. So S equal to V square upon 2A. Substituting W equal to ma multiplied V square upon 2A equal to half mv square. The work done is stored. This work done is stored as kinetic energy. Therefore, K equal to half mv square. Question number 64. The kinetic energy of an object of mass m moving with velocity of 5 meter per second in 25 joule. What will its kinetic energy when its velocity is double? Answer: K. Kinetic energy proportional to v square. If velocity is doubled, kinetic energy become 2 square or 4 times. New kinetic energy equal to 4 multiplied by 25 joule 100 joule. What is the energy stored in food? Chemical energy. What energy is stored in food? Question number 6. What is the source of energy for sun? Nuclear fusion, conversion of hydrogen to helium. A ball is thrown vertically upward. What happened to its kinetic energy as it rises? Its kinetic energy decreases as it rises because its velocity decreases. Question number 68. What happened to the potential energy of the same ball as it rises? Its potential energy increases because its height is increases. Question number 69. A dry cell converts one form of energy into another. What is the transformation? Chemical energy into electrical energy. Question number 70. Name the device that converts mechanical energy into electrical energy. Electric generator, dynamo. Question number 70. Name the device that converts electrical energy into mechanical energy. Electric motor. Question number 70. A stage bow possesses which form of energy? Elastic potential energy. Question number 73. When the stage bow is released, what energy transformation takes place? Elastic energy is converted to kinetic energy of the arrow. Question number 74. A body is falling freely under gravity. What happened to its total mechanical energy? The total mechanical energy K plus P remain constant in air according with the law of conservation of energy. Question number 75. A force does 100 joule of work to displace a body by 5 meter. Calculates Calculate the force applied. W equal to F into S equal to 10 100 joule. F into S 5 equal to F equal to 100 joule upon F equal to 20 Newton. Now move to part 4, law of conservation. Part 4, law of conservation, application of HOT, question 76 to 100. Question number 76, a lamp consumes 500 joule of electrical energy in 10 seconds. What is its power? P equal to energy upon time equal to 500 joule upon 10 seconds equal to 550 watt. Question number 77, a man does 200 joule of work in 10 seconds and body does 100 joule of work in 4 seconds. Who is more powerful? Power of man 200 joule upon 10 seconds equal to 20 W. Power of boy equal to 100 joule equal to 4 seconds, 25 joule. The power is more powerful. Question number 78, a rocket is projected vertically upward. Explain the energy change involved. At launch, chemical energy of fuel is converted into heat, sound, and kinetic energy of the rocket. While moving up, kinetic energy decrease and potential energy increase. At maximum height, kinetic energy is minimum, but no, not zero. If it has horizontal velocity, potential energy is maximum. Question number 79, a pendulum is oscillating. Why does it eventually stop? It eventually stops due to air resistance and friction at the pivot point. The mechanical energy is dissipated as heat and sound energy to the surrounding. Question number 80. A body of mass 2 kg is thrown vertically upward with a velocity of 10 meter per second. Find the maximum potential energy at the highest point, G equal to 10 meter per second. Answer. At the highest point, kinetic energy become zero by the law of conservation of energy. Initial K equal to final P, half mv square equal to mgh. Therefore, Pe at highest point equal to half multiply 2 kg multiply 10 meter per second square equal to 100 joule. Question number 81. What is the work done by the force of 20 Newton in moving an object through a distance of 4 meter in its own direction? W equal to F into S equal to 20 Newton and multiply 4 meter equal to 80 joule. 80. A person hold a bundle of hay over his head for 30 minutes and get tired. Has he done some work or not? Justify. No, he has not done any work in the scientific sense because there is no displacement of the bundle of the hair. Question number 83. How is work done by force measured when the force is variable? The work done by the variable force is measured by calculating the area under the force displacement graph. Question number 84. A girl sit on the swing and does not move. Does the possess energy? Yes, she possesses potential energy, gravitational energy due to her position above the ground. Question number 85. What is the relationship between kilowatt per hours and joule? 1 kilowatt hours equal to 3.6 multiplied by 10 to the power 6 joule. Question number 86. An object of mass 40 kg is raised to height of 5 meter above the ground. If the object is allowed to fall freely, what is its kinetic energy when it's halfway down? G equal to 10 meter per second. Total PE at top mgh 40 kg multiplied by 10 to power meter per second and multiplied by 5 meter equal to 2000 joule. At halfway down, height equal to 2.5 meter. PE at halfway 40 multiplied by 10 multiplied by 2.5 equal to 1000 joule. By the conservation of energy, total energy equal to 2000 joule equal to PE plus KE equal to 2000 1000 KE. Question number 87. A car is accelerated on a level road and attain a speed of v. What is the work done by the resultant force on the car? The work done is equal to the change in its kinetic energy. Question number 88. Can any object have momentum without having energy? No. If an object has momentum p equal to mv, it must have velocity and therefore it must have kinetic energy k equal to half mv square. Question number 89. Can an object have energy without having momentum? Answer: yes. An object can have potential energy while being at rest and having zero momentum. Example: a book and on table. Question number 90. The potential energy of a freely falling object decrease progressively. Is this a violation of the law of conservation of energy? Why? No, it is not a violation because as the potential energy decreases, the kinetic energy increases by the same amount. The total mechanical energy remains constant. Question number 91. A light and a heavy object have the same momentum. Which one has greater kinetic energy? The lighter object has a greater kinetic energy. Proof: P equal to m2. So V equal to P upon m. K equal to half mv square equal to half m p square upon m square equal to p square upon 2m. Since P is the same, kinetic energy proportional 1 upon n, the object with the smaller mass will have greater K. Question number 92. A light and a heavy object have the same kinetic energy. Which one has a greater momentum? The heavier object has greater momentum from K equal to P square upon 2m equal to P equal to root 2m upon K. Since Ke is the same, P proportional to 1 upon root m, the object with greater mass will have greater momentum. Question number 93. A person is standing with a load of 20 kg on his head. He is standing still for 5 minutes. What is the work done? Work done is zero because there is no displacement. Question number 94. What is the work done by the tension in the string of a simple pendulum? Zero because the tension force is always perpendicular to the direction of displacement of the ball. Question number 95. A sound wave is produced by the vibrating object. What is the work done by the object? Answer is the vibrating object does the work to compress and release the air, transferring energy in the form of sound wave. Question number 96. A mass of 10 kg is dropped from the height of 2 meter with the what velocity will it hit the ground? Equal to 10 meter per second. Using conservation of energy, PE at top, Ke equal to bottom. Mgh equal to half mv square equal to 10 multiplied by 10 multiplied by 2 equal to half multiplied 10 multiplied v square equal to 5b square. V square equal to 40. V equal to 40 to root 10 meters, approximately 6.3 meter. 97. A girl is carrying a school bag of 3 kg on her back and moves to 20 meter on a level road. What is the work done against gravity? Zero. Because the displacement is horizontal while the force of gravity is vertical. Question number 98. What is the power of pump which take 20 seconds of lift 100 kg of water to a height of 20 meter? Gram equal to 10 gram. Answer: work done W equal to mgh 100 kg multiplied 10 meter equal to 20,000 joule. Power P equal to W upon T. 20,000 joule equal to the 20 second equal to 1000 watt equal to 1 kV. Equal to 90. Question number 90. If an electric iron of 1200 watt is used for 30 minutes every day, find the energy consumed in the month of April in kilowatt per hour. Power 1200 watt 1.2 kilowatt time per day. 30 meter equal to 0.5 per hour. Energy per day 1.2 kilowatt for the 0. Per hour equal to 0.6 kilowatt per hour. Energy in April is 30 days 0.6 kilowatt hour per day. 30 days equal to 18 kilowatt per hour. Justify work and energy have the same SI unit. The SI unit of both work and energy is the joule because energy is defined as the capacity to do work. When work is done an object, an equal amount of energy is transferred to it. Question number 100. Justify work and energy have the same SI unit. The SI unit of both work and energy is the joule because energy is defined as the capacity or to do work. when work is done on an object, an equal amount of energy is transferred to it. Question number 100. Justify work and energy have the same SI unit. Question number 100. Justify work and energy have the same SI unit. The SI unit of both work and energy is the joule because energy is defined as the capacity to do work. When work is done on an object, an equal amount of energy is transferred to it. Question number 100. Justify work and energy have the same SI unit. The SI unit of both work and energy is the joule because energy is defined as the capacity to do work. When work is done on an object, an equal amount of energy is transferred to it. I hope this extensive list help us you master the chapter work and energy. But best of luck with your studies. गाइज ये वीडियो थी, हमने 100 क्वेश्चन डिस्कस किए. तो गाइज ये वीडियो आपको अच्छी लगी तो प्लीज़ लाइक एंड सब्सक्राइब जरूर करें. जय हिंद, जय भारत.